All right, so here is a similar triangle problem, and let's solve it together. To start off, I need to prove that this is a similar triangle. I need to prove two triangles within this figure that are similar. And the way that I'm going to do that is by finding different angles that are the same. Because remember, in a similar triangle, all angles are the same, right? It's only the side lengths which are different, but they are proportional um, to the other triangle. But either way, all we need to know is that the angles are the same. And if I'm looking at this diagram, I already know that the angle S, which I'm assuming to be 90 degrees, not in its acute form within this triangle, that is going to equal the 90 degrees by that are given to angle T. Okay, so now we've already proven one pair of angles, which are true. Okay, now let's try to find another angle that can be present in two different triangles, right, separately. And what I'm seeing is R to be that case. So what do I mean by that? Well, I'm going to say triangle R is equal to triangle R. And all this is saying is that this R value can be used by multiple triangles because you could use it in this case, right? But you can also use it in this case as well. See, the R is still being used. So therefore, all we say is that angle R equals angle R because they are belonging to different triangles. Okay, so so far what we've done is we've described SR, right? So S and R. So we've described this length and then TR, this length here. So what is remaining now? Well, if you look in these two lengths, right? If you want to complete the triangle, well, you're forgetting Q. So angle Q. Now what would that equal? Well, let's try to complete this triangle, the red triangle. So we have TR, that's okay, right? So what is the remaining angle that we need to complete the triangle? Triangle is three angles. Well, that's S, right? Because if we get that S, right, we can completely create a triangle. So that's going to be angle S here. Okay. So the justifications that you can give is that here both equal to 90 degrees. Um both present in like they're both present in both of the triangles. So I'm just going to say both present. And then here you can say remaining, I'm just going to write R, remaining angles to complete complete triangle. To complete triangle. All right, so that's the justification that we're giving. All right, so now this column is one angle, or sorry, one triangle, and this column is one triangle. So we have triangle and then SRQ. So SRQ, which is similar to triangle TRS. TRS. Okay? It's very important that you write it in the proper way. That's why when I'm proving it, I like to write the angles and their correlation with each other first, and then I like to write the similarity statement, which I just completed over here. Okay, now we have proven these two triangles, SQR, so the big triangle with the smaller triangle, like the red one that I've highlighted. So we've proven that to be similar. All of that's good, all well and done. Okay, all right. So now what do we do? Well, we need to find the side length of x. And so x is the side length of s and t as well. So you could express it as either st, right, or x, because that value is assigned, or that side is assigned to the value of x. All right, both of these are acceptable. But before we do that, we need to set up our proportional statements. Okay? And the way that we're going to do that is by looking at this figure again. All right? We're going to look at this figure again. I accidentally stopped recording. There we go. Okay. All right. I'm just gonna bring the figure in again because we annotated this one, right? All right. Let me just make this a little bit bigger so we can actually see it. Okay, cool. So we have this figure. It's the same one as the above. I just brought it down so we can do more annotating on it. Okay, so what we need to do now is we need to figure out the different lengths. All right, and so on each triangle, there's going to be three different lengths. So, and then based off of those lengths, we can create a proportional statement, right? Because remember, the lengths, the proportions of them, or the ratio of the corresponding lengths, right? They are equal to one another, and you create a corresponding side with the angles, like which are related to the lengths, which are equal on both of the triangles. So here's how it would go. So let's say in triangle SQR, let's look at, or let's target Q and S, right? Because we're looking at this particular triangle, right? So we're looking at Q and S. So the side of Q and S. So that is part of this angle. All right, this triangle, I should say. So the Q, its same value on the other side is S, and then the S on the triangle SRQ, its similar value, the same value, is T. So if we look on the smaller triangle now, ST or TS is this value here. All right. All right, so now we're going to write equals to and then build another proportion. So we have to start again with the bigger triangle. So let's pick on another value. So let's say Q and R. Okay, now we got to do the same thing at the bottom. So with Q and R, so again, you would have the S, right? The S, because remember the Q on the SRQ, triangle SRQ, equals to the S on the TRS. And then the R, well, that equals R on the TRS too. So we have built our next proportion. But remember, there are three lengths. There are three lengths. So we have to build one more proportion. Because remember, proportion has one length, or each length, um, like for each length, you're gonna have one proportion, right? Okay. So again, looking at the bigger triangle, let's say SR. SR. Okay, so that's this length over here. And so now we have to find the corresponding length. So what would the corresponding length be? Well, it's going to be S, which is T, and then R, which just equals R. All right, so now we've built our proportional statements. Now let's go ahead and substitute whatever values we can. So QS is 12. Now ST or TS is X. That's going to equal QR, which is 20, and then SR, which is 16. And that's going to equal SR, I apologize, Q r. Yeah, sorry, that makes sense because this value is shared with both of the. Sorry, I got a little confused for a second. Okay, now the SR again, that's just gonna be 16, and the TR is going to be 20. Sorry, TR. We don't know what that is, so I'm just gonna write for TR. For TR, I'm just gonna write a value of y. Let's say. All right, so let's just say it's y. Okay, we don't need to really worry about this value because it's really this that we're concerned about. But TR, right? TR is from here to here, right? Okay, let's start solving this now. So you don't really need to worry. You don't need to worry about this value here because we're not really dealing with TR. We don't really care what the value of TR, that side length is. It's really X that we're concerned about. Okay, so here we have this proportion now. So let's try to figure this out. So let's say that again we're just taking this out of the equation for now, right? So I'll just take this out of the equation for now. And so let's say in this case, right, we can do cross multiplication, right? Because we're using fractions, and we have an unknown value in the fraction. So we're gonna say 20x is equal is equal to 12 times 16. Okay, 12 times 16. So then what we're going to do is we're going to do 20x, right? 20x, which equals, and then you're going to do 12 times 16, which is 192. And that's going to be divided by 20. And that's going to be divided by 20. And so then x is going to equal 192 divided by 20, which is 9.6. All right. So now we know the x value to be 9.6. Now let's bring this this proportion back into the equation. And so you don't have to, but if you wanted to figure out the side length of TR, you could do the same thing. Let's take the same proportion again, right? So the 20 over 16, and let's do cross multiplication. I'll use a different color so we can differentiate visually. And so when we do that, you're going to get 20y, which equals, and then 16 times 16. So then 20y is going to equal the 16 times 16, which is 256. And then you have to divide the 20. This is basic algebra, so I'm not really explaining it because I kind of have that expectation of you knowing it. But if you don't know, you just search up isolation algebra. And then so then the y is going to just be the 256 divided by 20, which gives us 12.8. 12.8. All right. So that's how we were able to just. This is just extra work that I did over here. So even if you're still in the video right now, this work that I did is just extra work. You don't really need to do this, right? You don't really need to do this part. But anyways, that is how you can kind of work with similar triangles to figure out a specific proportion. So you want to make sure that you make this. This is your proportion statement. Proportion statement. And then with that, you can kind of substitute things in and then figure out the different unknown values.